Welcome to this video on rational equation word problems, part 1 of 3, work problems. Let's begin. So before we begin our first example, let's talk about some general strategies that we can use. First of all, we can circle or underline important words or phrases. We can label important information. This includes assigning variables to unknown quantities. We can also organize our information using tables or pictures. Lastly, we can make predictions about what a reasonable answer would be. For example, it doesn't make sense that a car would be traveling at 300 miles an hour, or that a plane would be traveling at only, say, 20 miles an hour. Also, we can't really have values of time that are negative, like -2 seconds, or negative distance. You can remember these strategies by memorizing the anagram CLOP. So C is for circle, L is for label, O is for organize, P is predict. Let's use these strategies in the first problem. Example 1 says Joe can mow, weed, and edge a lawn in 4 hours. 4 hours sounds important, so I'm going to circle it. Mike can do the same amount of work in 3 hours. 3 hours sounds important, so I'm going to circle it. Then it says, how long will it take them working together? That's the unknown quantity, so I'm going to highlight that. And then I'm going to label it, and I'm going to say that X is the amount of time to complete the job if they work together. Okay, so notice I've already created a table for us here. So the first column is the time, the amount of time that it takes them to complete the job. So let's fill in the table based on what the problem says. The problem says that it will take Joe 4 hours to complete the job all by himself. It says that Mike will take 3 hours to complete the job all by himself. Okay, so if we go back to our strategies, we have circled everything, we've labeled by assigning a variable, we've organized our information. Now let's make a prediction about the answer. Okay, we don't know how much time it's going to take them to complete the job, but we already assigned it a variable. We said that it's going to take them X hours to complete the job, so we can put X there. So do we expect X is going to be larger or smaller than 4 or 3? Well, if Mike can complete the job alone in 3 hours, and somebody's helping him, does that mean that it's going to take more time or less time if he's getting help? You would imagine that if somebody else is doing part of the job for him, that the overall time that it takes is less than 3 hours. You could also make the same argument. If Joe was working by himself and he can do the job for 4 hours, in 4 hours, you would imagine it would take less time for Joe to complete the job if he's getting help. So the answer should be less than 3 hours and less than 4 hours. Okay? So now what do we do? Well, now we have this second column. This is actually R. This is my rate. This is my time. This is my rate. So we're making an assumption here, which is that they're working at a constant speed. So if Joe gets the whole job done in 4 hours, in 1 hour, we're going to assume that he gets a quarter or 1/4 of the job done. Right? So the first hour he gets a quarter of the job done, the second hour he gets another quarter done, and so on and so forth. Likewise, if Mike can get the whole job done in 3 hours, assuming a constant rate of work, we assume that he can get 1/3 of the job done in just 1 of those hours. Okay? Likewise, together, if they take X hours to complete the job, we assume that they get 1/X, part of the job done in 1 hour. Now we've already kind of made it clear that doesn't make sense to add 4 plus 3 and get 7 for our final answer, right? Because again, if they're working together, the amount of time it takes them should be smaller, not larger, than the time it takes them by themselves. Even though it doesn't make sense to add 4 and 3 together to get X equals 7, it does make sense to add 1/4 and 1/3 together. Let me explain. So Joe, in 1 hour, gets 1/3 of the job done. In that same exact hour, Mike is getting a quarter of the job done. If we add these together, we should be able to find out what fraction of the job was completed in that first hour. So that's equal to 1/X. So this is our rational equation that we can then use to solve the problem. So I've pasted here the list of steps that we need to use when we solve a rational equation. Now, if you need to review that, please go back and watch the video on solving rational equations. I'm going to assume at this point that everyone knows how to do that. So the first thing we need to do is we need to find our LCD. So my LCD in this case is going to be 3 times 4 times x, or 12x. My next step is to multiply all of the terms by 12x. So 12x, 12x, 12x. Okay? If it makes you uncomfortable to do this, you can also write 12x over 1 in case you forget or you get confused about what is getting multiplied by what. So 12 divided by 3 is 4. 12 divided by 4 is 3. And over here, the x's cancel out. So I have 4x plus 3x is equal to 12. Well, that is a simple linear equation that I can very easily solve. So let's do that third step, solving for x. Well, 4x plus 3x is simply 7x. So then we just divide by 7, and we find that x is equal to 12 over 7. Now, in a lot of problems, I prefer improper fractions because it's an exact answer. But when you're working with word problems, you're really trying to contextualize your answer. So for example, if your mom said, hey, how long is it going to take you to do the lawn today, working together, and you said, it's going to take me 12/7 of an hour, that's not very useful to the common person, right? So we're going to actually divide that. 12 divided by 7, I'm rounding to the nearest tenth, is 1.7. Okay, again, you can just type that into your calculator. So it's going to take them working together about, you can write about if it upsets you that you had to round, it's about 1.7 hours. Okay? Again, in more problems, we always write it as a decimal because it makes more sense. And we need to include the units, right? 1.7 what? Is it hours, minutes, days? How long is it going to take? You want to know. So let's compare this answer to our guess, right? Our guess was that it was going to take less than 3 hours. Is 1.7 less than 3? Absolutely, it is. It makes sense in the context of the problem. It makes sense that if two people are working together, one who takes 4 hours to do a job, one who takes 3 hours to do the job, if I told you that working together they would take about 1.7 hours, that seems reasonable. All right, let's do another example. This one says one pipe can fill a pool in 15 minutes. So let's circle 15 minutes. Okay. Well, a second pipe can fill a pool in 20 minutes. How long will it take both pipes working together? Again, I'm going to assign this the variable x. Okay, x is the amount of time it takes both pipes working together to fill the pool. Also, I just want to correct this. Since our time is in minutes, we need to change this to minutes here in our table. Okay, so let's fill out our table. So pipe 1, we said that it's going to take 15 minutes. Pipe 2 is going to take 20 minutes. Working together, we don't know, but we did assign it a variable. We assigned it the variable x. It's going to take x minutes working together. So if it takes 15 minutes for the pipe to fill the pool, then if we assume a constant water flow rate, mass flow rate, then 1/15 of the pool would be filled up in a single minute. Likewise, 1/20 of the pool would be filled up by pipe 2 in 1 minute, and working together it would be 1 over x. Okay, so remember this is our time and this is our rate. Okay, so just like in the last problem, we say that if I can fill up 1/15 of the pool in 1 minute, the other pipe fills up 1/20 of the pool. If I add those together, that gives me the amount of the pool that's been filled up in 1 minute. And then I can use this to solve for x. Okay, so again, we want to find our LCD. 15 is 5 times 3. 20 is 5 times 4. So my LCD is 3 times 4 times 5 times x, or 60x. Okay, so I need to multiply each fraction by 60x, and then I can simplify it. So 60x here, 60x here, 60x here. Okay, so 60 divided by 15 is 4, 60 divided by 20 is 3, and over here the x's cancel out. So this gives me 4x plus 3x is equal to 60. So in other words, I have 4x plus 3x. 4x plus 3x is 7x. So we have 7x is equal to 60. Divide both sides by 7, we get x is equal to 60 over 7. Again, not super helpful to the common person, right? So we're going to turn it into a decimal. I'm going to round to 1 decimal point. This rounds to about 8.6, oops, not hours, I apologize, 8.6 minutes. Okay, so we didn't make a prediction here, but let's go back to our original problem and make sure that this answer makes sense. So if it takes one pipe 15 minutes and the other pipe 20 minutes, right, you could imagine working together, it would be somewhere about half, right, about half of that time. So half of 15 is 7.5, half of 20 is 10. So 8.6 is somewhere in between 7.5 and 10 minutes. So that really does make sense. It makes sense that working together, it would take them about 8.6 minutes to fill the pool. All right, let's do one more example. This one is about painting a room. So let's go first and circle all of the important information. It says Bob can paint the room in 5 hours. And then it says that Jan can paint the room in 4 hours. So I guess Jan's a little faster. Okay, and then it says how long will it take them to paint the room if they work together. Okay, so remember that last thing is usually our variable. So I'm just going to call that x. Now notice here I did not fill out the table for you. So part of the skill that you need to learn is not just how to put in the values from the problem, but also how to label your columns and rows. So let's practice that skill. So we have two people. We have a Bob and we have a Jan. Okay, and then the last row is always working together. Okay, then our two columns are our time and our rate. Okay, so time and our rate. So let's see if we can fill this out. So Bob takes 5 hours to paint a room. Jan takes 4 hours to paint a room. We don't know how long it takes them to work together, so we'll just say x. Okay, our rate. Again, assuming a constant rate, we say that Bob can get 1/5 of the job done in 1 hour, Jan can get 1/4 of the job done in 1 hour, and working together they can get 1 over x part of the job done in 1 hour. Okay, so again, just like last time, we have 1/5 plus 1/4 equals 1 over x. Okay, in this case, our LCD is going to be 20x. So we are going to multiply all of our fractions by 20x in order to get rid of all of our denominators. 20 divided by 5 is 4. 20 divided by 4 is 5. Oops. And then over here, the x's cancel out. Again, I invite you to remember that this is really 20x over 1. So if you get confused about what is getting multiplied or what is getting divided, you can use that trick to help you. Okay, so we have a 4x plus a 5x is equal to 20. In other words, 9x is equal to 20. And then we divide. And again, normally I would say just leave it as an improper fraction and walk away. However, in this case, we really want to contextualize it, make it make sense to somebody who's not in a math class. So when I divide it, I get about 2.2 hours. So let's go back and make sure that this makes sense in the context of the problem. We didn't exactly make a specific prediction, right? But we did say that it should take less than 4 hours, right? And 2.2 hours is less than 4 hours. So it makes sense that working together it would take about, somewhere between half of 4 and half of 5 hours. So 2.2 is right in the middle of that. So that is our answer.